Assalamualaikum and good day to everyone. My name is Irne Aida Binti Muhammad Nasir, and I'm a Bachelor Engineering student at Faculty of Electronic and Computer Engineering. So today I will present my bachelor degree project titled of Synthesis of Nickel Oxide Quantum Dot as Hall Transport Layer for Solar Cell Application. So for the project overview, firstly, a solar cell is a device that uses photovoltaic effect to directly transform energy into electrical energy. After that, the generation of solar cell have improved and developed. Next, perovskite solar cell led to a growing demand because of their stability and higher mobility. Because of that, extensive research focused in particular synthesizing nickel oxide in the form of quantum dot as a Hall transport layer. So, moving on to problem statement. First, poor stability of P.PSS as a Hall transport layer. This is because the large particle size of P.PSS induces degradations of the device because the aggregation of particles causes defects. Second, perovskite solar cell degrades easily by moisture. And third, the high cost on low electrical conductivity limits the use of P.PSS as an efficient Hall transport layer. Next, for the objective, first is to simulate a layer of solar cell as a Hall transport layer in perovskite solar cell using GPVDM software. And second is to synthesize nickel oxide in the form of quantum dot as a Hall transport layer that will enable higher solar cell power conversion efficiency. And last is to characterize and analyze quantum dot using X-ray power diffraction, characterization using scanning electron microscopy for comparison of structure, and UV visible spectroscopy for the interaction of incoming light with the sample substance. In the next slide, I will show you how I simulate solar cell layer using GPVDM software. So for the software using GPVDM software, this is the open windows. As you can see, there's layers FTO, nickel oxide quantum dot, perovskite, zinc oxide, and metal. And then this is the layers parameters where we can change the materials to active, contacts, or others. Besides that, we can also change the material using the database that's given or manually edit it in the database. Next, click the electrical parameters to change the constant value of nickel oxide quantum dot or perovskite or other materials like band gap or electron affinity. After changing the values, we run the simulation and wait it until the output result is out. So moving on, we click output and then click sim.info.dat, and the parameters result can be seen and analyzed from here, where we can see here that there's a field vector, and then we can see that there's open circuit voltage, next current density, and then there is also power conversion efficiency. And from this, analysis for nickel oxide quantum dot and comparisons between other materials can be made. So from this analysis, I can say that nickel oxide quantum dot can be obtained because the power conversion efficiency is supposed to be higher than basic nickel oxide. Besides that, using GPVDM software,
We can also see the electron move in the layers of solar cell by run the simulation in optical simulation. Here we can analyze the photon distribution that is absorbed, and photon density, where this is the flow electron that is flowing in the nickel oxide and perovskite.
So next is my experimental video in lab in making nickel oxide in the form of quantum dot as a Hall transport layer.
Moving on to experimental towards nickel oxide quantum dot, we prepare the solutions, that is dissolve 0.622 gram nickel acetate tetrahydride in 15 ml ethanol plus 10 ml IPA. Then we add 0.56 potassium oxide plus 100 ml water to reach desired pH. Then, after dissolving the nickel acetate, the mixed solution for potassium oxide is drop by drop at the nickel acetate solution until it obtains desired pH. Next, after obtain the desired pH, wash the mixed solution until top layer and bottom layer can be seen. Next, remove the top layer using syringe and put it in another beaker. After that, the bottom layer is washed again with ethanol and then let it rest again until we see the top layer and bottom layer. The step is then repeated 5 times. Then the solution is sonicated for 30 minutes until it obtains a gelish solution. Moving on, coat the surface of the glass with the nickel oxide quantum dot solution using spin coater for 3000 rpm with 30 seconds. After that, dry the glass in the oven and repeat it 10 times for 10 layers. After finish, the characterization of nickel oxide quantum dot can be made by using UVVs, furnace, XRD, 4-point probe, dielectric constant, after that SEM. So this is the result for nickel oxide quantum dot for lab experiment analysis for pH 9. So this is what it looks like before anneal and after anneal at the temperature for 700, 800 and 900 degrees Celsius. So we do the annealing for top layer and bottom layer. Next is analysis for SEM. This is for the top layer. SEM is the electron in the beam interact with the sample, resulting in a variety of signals that may be utilized to determine the surface topography and composition. So this is for the SEM analysis for bottom layer. There is the nickel oxide, you can see there. And next for UV-vis analysis, absorption spectra. The absorbance spectrum can be used to study the interaction of incoming light with the sample substance. So this is for the dielectric constant analysis, where it provides direct real and imaginary permittivity measurement as a function of temperature and frequency. The dielectric constant is the actual permittivity. So this is for the top and bottom layer and for different temperature. And next is the XRD, X-ray power diffraction characterization. Here we can see the peak is to determine that there is a nickel oxide exists in the graph.
So as you can see, this is my methodology for both, that is in lab experiment and GPVDM software. So starting with lab experiment is first I will start and then I prepare a glass substrate and then I will synthesize the nickel oxide quantum dot. After that, I will spin coating as you can see in the previous video that I've showed you, and then drying at the oven. After that, I will anneal it, and then we continue with the material characterization. If I have achieved nickel oxide quantum dot layer, then it will be N, and if not, I will start synthesizing it again. So moving on to the GPVDM software methodology is, first I will start it and then I will simulate it using GPVDM, and then I will synthesize for nickel oxide quantum dot, that is mean I will run it, and then after that I will characterize and analysis the nickel oxide quantum dot structure. After that I will compare it with previous paper in perovskite solar cell. After I've achieved it, then it will be N, and if not, I will start synthesizing it again. So for the environmental sustainability, I've chosen the Sustainable Development Goal for number 7, that is affordable and clean energy. This is because it expands supply in sustainable energy, and next it ensures universal access to energy service, and then a double improvement energy efficiency. So next, for the marketability, first it is safety hazard because the material is in form of organic, and then it is low cost because the price for making nickel oxide quantum dot is quite cheap comparing other materials. And lastly is energy saving because the efficiency high and can last longer than other Hall transport layer. That's all from me. Thank you.